All right, let's jump right in. When we talk about making retrieval-augmented generation, RAG, smarter, everyone's first instinct is to just throw more data at it. Bigger databases, more documents. But what if I told you the real bottleneck, the place where these systems truly break down, has nothing to do with size? It's all about intelligence, specifically how we prep our data long before an AI ever sees it.
And this really gets to the core of the paradox we're digging into. Chunking, this basic, fundamental step of chopping up documents for an AI, it's absolutely necessary. But as you're about to see, the way most people have been doing it can actually sabotage the entire system, leaving you with broken context and answers that are not just wrong, but dangerously wrong. So here's how we're going to trace this story. We'll start with the problem itself. Then we'll rip apart the most common and flawed approach. From there, we'll walk through the smarter solutions engineers came up with, and finally, we'll get to the real game changer, a system that adapts not just to the data, but to what you, the user, are actually asking. And of course, we'll look at the hard numbers that prove why this leap is so important. Okay, first things first, let's get grounded in why this matters so much for anyone building a serious AI app. You know the biggest problem with any large language model, right? Its knowledge is frozen in time, and often it's just plain out of date.
And that's exactly where RAG becomes the hero. Think of it like this diagram shows. RAG is the bridge that connects the model's brain to the real, live, up-to-the-minute world of your company's data. Before it even thinks about answering, the system goes out and fetches relevant, current information to give it the right context. This one move is our single best weapon against AI making stuff up, what we call hallucinations, and it's totally non-negotiable for high-stakes work in fields like finance or law. Now, at the very bottom of this entire RAG pipeline, you have chunking. It's pretty straightforward. You can't just stuff a 400-page annual report into a model's context window, so you have to break it up into these smaller, bite-sized pieces. These chunks are what get vectorized, indexed, and ultimately found by the system. It's a basic mechanical step you have to do. And this is the whole point. For way too long, engineers treated chunking like some minor chore you just get over with. But what we know now is that it's one of the most important architectural decisions you'll make. Your chunking strategy pretty much dictates the relevance, the coherence, and ultimately the accuracy of your entire RAG system. So let's talk about the most popular chunking strategy out there, which also happens to be the most broken. I mean, for a precision job like finding the right information, fixed-length chunking is like using a sledgehammer to perform brain surgery. Look, I get why people like it. It's simple. You just tell the machine, chop this document into 512 token pieces and don't ask any questions. It's predictable, it's easy to debug. But here's the massive problem. Ideas and meaning don't care about your arbitrary token count. This method just bulldozes right through the semantic flow of a document, leading to what I call semantic destruction. Let's make this painfully real. Imagine you're analyzing a legal contract. The system goes to work, chopping it up. A crucial liability clause gets split right down the middle. The first chunk ends with, shall not be held liable for damages resulting from, and the next one starts with, force majeure events. That critical connection between the two, gone. The link is completely severed.
So what happens next? A user asks about liability, and the system might only retrieve that first fragment. The model, working with half the story, spits out an answer that isn't just a little bit wrong, it's dangerously misleading. It might confidently say a company has zero liability, totally missing the crucial exception. This isn't a small bug. It's a complete, catastrophic failure of the system's purpose.
Okay, so obviously this brute force approach was a disaster waiting to happen. It forced the whole industry to get smarter. The mission became clear. We have to split documents in a way that actually respects the meaning inside the text. This evolution kind of happened in waves. First, you got semantic chunking, which uses embeddings to find natural breaking points where topics change. Then, a huge step forward, document-aware chunking, which is smart enough to use the document's own structure, like headings and paragraphs, as natural dividers. And that led to one of the most powerful strategies we use today, parent-child chunking. The idea is brilliant. You search for a tiny, specific child chunk, but you feed the LLM its much larger, context-filled parent chunk. And the results here are huge. We're not talking about a small improvement. The parent-child pattern really gives you the best of both worlds. You get the laser focus of small chunks for finding information and the rich, deep context of big chunks for generating an answer. It consistently delivers a solid 10 to 20% boost in answer quality. For a long time, this was the gold standard.
But even these really clever strategies have one big thing in common. They're all static. They prep the data one way, and that's it. It doesn't matter what the user is trying to accomplish. The next massive leap forward was to make this whole process dynamic, to make it responsive. And that brings us to the cutting edge of high-performance RAG, dynamic granularity adjustment. It sounds a bit technical, but the idea is actually pretty simple. Instead of a one-size-fits-all chunking strategy, the system actually tailors the size and scope of the information it retrieves based on your specific question. The system literally adapts on the fly. So how in the world does that work? Well, the first and most critical step is that the system has to figure out your intent. It doesn't just see a bunch of words. It analyzes your query to understand what you're really after. Are you asking a simple, targeted question like, what is X? Or are you asking a big exploratory question like, analyze the relationship between Y and Z? Let's go back to our legal AI. A user types in something straightforward. Provide a summary of the case. The intent detection system immediately flags this as a targeted, factual query. So the RAG system takes a very precise action. It retrieves a small, focused chunk, probably the one that contains the case's abstract or conclusion. It's clean, efficient, and dead on. Now, watch this. A different user asks something way more complex. Analyze the precedent relationships in this case. The system knows this isn't a simple lookup. It requires deep synthesis. And so its action is completely different. It dynamically pulls a much, much larger piece of context, maybe even stitching together multiple parent chunks that connect legal arguments, citations, and reasoning. This adaptability is everything. Now, this whole paradigm shift isn't just a cool engineering trick. It delivers real, measurable, and honestly, dramatic improvements in performance. This is the kind of thing that translates directly to business value. And here it is. This is the number that should make every AI architect out there sit up and pay attention. Systems that can actually detect user intent and adapt the chunk size see up to a 30% improvement in retrieval relevance. Let me say that again. 30%. That means the system is drastically more likely to find the right information on the very first try, which is the single biggest factor in getting a high-quality answer. So what does this actually get you? The benefits are huge. You get way higher accuracy and fewer hallucinations because the model has better context. Your answers are more coherent because the system knows when you need a quick fact versus a detailed explanation. It's even more efficient with computer resources since it's not grabbing huge chunks for simple questions. You end up with a system that is amazing at handling both the easy and the hard stuff. So I'll just leave you with this final thought. We've journeyed from dumb, static chunking all the way to intelligent, dynamic retrieval that literally responds to user intent in real time. And that forces us to ask a really fundamental question. If the way we access our data is becoming this profoundly dynamic, what does that mean for a future built on static data architectures? The whole game is shifting from just storing information to preparing it for a truly intelligent, adaptive conversation.